Hi, my name is Gil Poznansky, and I want to introduce you to some technology that will allow you to create anything you want without needing a manufacturing plant or millions of dollars. Welcome to the world of 3D printing. In today's video, we're going to look at what 3D printing is all about, the differences between traditional creation and manufacturing and 3D printing, how a 3D printer works as well as the parts of a 3D printer, what a 3D print is actually made of, the process to create and set up your own designs, and I'll also show you where to explore existing designs and practice basic skills. Let's go to it. Let's start with how we build something. Say we want to build something like this box. Think about what you would need to actually make this box. You'd need some material, maybe a saw and some knives, maybe a ruler. Depending on the material, you might need a drill, some screws. You definitely need some clamps and some glue to hold it all together. But what if you could do all of that at the same time? Introducing 3D printing, otherwise known as additive manufacturing. Additive because it creates by adding material in the areas that you tell it to. Now, 3D printers use a system called fused filament fabrication. Fused meaning to join together. Filament is talking about the material that you actually make the 3D prints out of. And fabrication is the actual act of creation. Think about it like this. Take a piece of paper and draw your design out on it. In this case, like the box. Then if we cut out that shape, we would actually have the design in our hand. We take two pieces of paper and we glue them together. And slowly, as we add material into it, it starts to get thicker. And as we repeat this maybe 10,000 times, we actually get a three-dimensional shape. We have a box happening right in front of us. This is exactly how your MakerBot 3D printer works, exactly in the same way. But instead of drawing and cutting out the design, the 3D printer traces the design on the print bed, depositing material, then moves the print bed down a small amount before repeating the process and adding depth to your design. Now the material cools off and fuses with the bottom layer, creating a solid object at the end of the print cycle. Your design can include anything you want. So if you wanted to create a part that bolts onto your bike, you can design the holes in the final piece with no need to use a drill afterwards. You have complete design control. Advanced designers have built parts that flex, joints that move, and parts that can interact. And the great part about this is it's completely repeatable. Once you're happy with your design, make as many as you need. If you need to change the design, you can make these changes digitally with design software. Make many of the same, or create custom parts, all can be done with your MakerBot 3D printer. Now 3D printers all come in different shapes and sizes, but they all have the same key components when making an object. Let me introduce you to the main parts of your MakerBot 3D printer. The extruder is what makes 3D printing possible. It draws out the design and places material on that print bed. On MakerBot 3D printers, all the extruders are enclosed and attached with magnets that can be changed out quickly following the instructions on the LCD screen on your 3D printer. This allows the extruder to move left or right or up and down, giving it full access to the area of the build plate. The Z-axis allows depth to the object, and this is created when the build plate moves down a small area and allows the next layer to be stacked upon the previous layer. Over time, this creates that three-dimensional object. The material used in a 3D printer is called plastic filament and is loaded into the filament drawer, allowing the MakerBot 3D printer to keep track of the material and use as much plastic as needed to make your print. Now the plastic itself is called Polylactic Acid or PLA, and it's actually biodegradable, which is great because it's a bioplastic and is made of sugar and cornstarch. This means that it's made from renewable resources and is much kinder to the planet. This plastic also has some great properties, such as a low melting point and is considered food safe, so you can design special cookie cutters on your MakerBot 3D printer and use them directly in your kitchen afterwards. Your MakerBot 3D printer uses computer-aided design software to create a blueprint of the part that you want to build. Free software such as Tinkercad will walk you through the process and create complex items in a format that your 3D printer will understand and create for you. More experienced with CAD and design, you also have the option to use advanced software such as Fusion 360 or SolidWorks to create a professional level print that you can get your 3D printer to build for you. Slicing creates instructions specifically for your MakerBot 3D printer and will tell your 3D printer where exactly to put material in the making process. Sound complicated? Don't worry about it. This process is actually taken care of by the software that runs your printer. The software is called MakerBot Print and makes this process really simple. By loading your design into MakerBot Print, you can slice your design and send it wirelessly to enabled MakerBot printers, or connect your printer directly using a USB cable. The great thing about MakerBot systems is that for people beginning their 3D printing journey, you can let the software guide you with your print settings, allowing you to adjust how big you'd like your item, or where you would like it to be on the print bed. Then it's as simple as creating a preview of the process, which tells you how long it's going to take to build the item, as well as how much material you're going to use before sending the design to your 3D printer. So I can imagine what you're thinking. So Gil, I need to design something in CAD and then take it to MakerBot Print to get my 3D printer to print an item? I don't even know where to begin. Don't worry, I know I had the same thoughts when I bought my first MakerBot 3D printer. You are now part of the MakerBot community that not only wants to help you with your 3D printing journey, but are happy to share CAD designs so you can familiarize yourself with the process and make some really cool objects at the same time. Welcome to Thingiverse, MakerBot's online community and repository of designs that you can download and print out with your MakerBot 3D printer. Thingiverse holds items across a gamut of subjects, such as art, fashion, hobbies, toys, and more. Thingiverse is like an online encyclopedia of objects that you can freely access. And the really cool part about it is that Thingiverse is integrated directly into MakerBot Print, meaning you can search the website, find a design, and send it to MakerBot Print in just one click. And when you're ready to design your own items, you too can share your creativity on Thingiverse for others to print and explore. Over the last few years, domestic 3D printing has allowed thousands of people to create and express themselves. From palm-sized drones, futuristic interpretations of classic musical instruments, a portable version of a well-known game, a futuristic chainmail for astronauts and spacecraft, or a prosthetic limb for someone in need, you're only limited by your creative desires. Think about what you would like to share with the world. 3D printing will allow you the tools to create your design, prototype it, and take it from an idea to an object that you can share with everyone. We here at MakerBot can't wait to see what you're going to create with your MakerBot 3D printer.